welcome guys. So today let me just try to so this is a very cute lecture. So what I try to is introduce some square identity. Okay, so the first identity what I want to show is that this is a defender's identity. So this one is very famous. This one, right? So a squared plus b squared times c squared plus d squared equals to AC minus BD squared plus AD plus BC squared. Okay, so the proof is really simple, right? You just expand it. So we can just expand it. Right, so this is ABCD. And then you added this. Right, so these two terms canceled, and you get this. Also, you get this. Okay, and then there's also a useful and a more general identity. Basically, there's n here. And this is also a very simple one. Okay, and the next one is the Euler four square identity. This is a1 plus a1 squared plus a2 squared plus a3 squared plus a4 squared times this, right, equals to this. Right, so basically the position we fix is a1 to a1, a2 and a3, a4, but the b1, b2 are somehow like shift. And for each terms, there's always so this is 3 minus term, 2 plus terms, 1, 2 plus terms, 2 plus term. And the proof can be seen as the quaternion. So I can let alpha to be this, beta to be this. And this ij can satisfy the properties ij equals to k, jk equals to I, ki equals to j, and the ji equals to minus k, kj equals to minus I, ik equals to minus j. Okay, and the conjugates is basically change I to minus I, j to minus j, and k to negative k. So we will have this, right? And the norm is basically defined to be alpha times alpha star. So we get this and this. And the product AB is basically alpha times alpha star, beta times beta star, where beta star is a real number right here. Okay, so we will have this. Since this is a real number, so we can somehow like the shuffle it, right? So we get this. Okay, so we can get this one, right? Because one can one can check that this alpha beta conjugate alpha conjugate. So this is gamma times gamma star. Gamma is just alpha beta. Okay, so we can just compute the Hamilton product, basically the quaternion product of alpha beta. And the computation is very tedious, but finally you get this, right? And the gamma star. So if you take their conjugates, you get this four square terms, which will definitely equals to original AB product. Okay, and there's a brute force. Basically, one can just use Mathematica. So this is the code I write. So basically, just give these 2 square, and then minus 4 square terms, and then do the 4 simplifications, and finally you will get zeros. So these terms are just the previous term I write. Okay, and this is a Pfister identity. So another 4 square identity basically follows like this. So there's an additional U1 and U2 terms. Basically, you can Google to search this. And then this U1 is this, U2 is this, and we need this. Basically, I don't know other proof of this identity, but I know one can use brute force, right? So this is the brute force to prove this Pfister identity, and then this is a Mathematica code, so you guys can copy and check whether it's correct. So finally, you get this one is 0, right? So this is the 4 square, and then you put the U1 definition and the U2 definition. Basically, it's these 2 guys. Okay, the next one is the Degen's A square identity. Okay, so this is much complicated, but the idea is basically exactly the same. Yeah, you can use the Octonian Algebra. So basically, you can write x equals to this one, and the conjugate is, and the same reason is xx conjugate will be the sum of this xi squared. And then you can use so this is norm. And then we have this property, right? Nxy equals nx and y. So basically, you just take compute xy products and doing each term square and check them. So basically the key idea is the same as the Octonian. So then you can prove this this A square identity. Okay, so it's a very short video, and I will see you guys in the next videos. Be sure to subscribe to my channel.